In this video, we're going to take up the logarithms homework sheet. We actually have two homework sheets, and this is the first one. So the first question asks us to rewrite it in logarithmic form. So they give it to us in exponential form, and you just have to write in logarithmic form. So the base of the power is the base of the logarithm. The argument is what the power is equal to when you evaluate, what the logarithm is equal to is the exponent at that base and at that value. Number two, they're asking us to rewrite in exponential form, so pretty much the same idea as question one, just reversing it. Number three, evaluate without a use of a calculator. So for these questions, you just need to know your powers, like 8 squared, 64. 2 to the power of negative 6 is 1 over 64. 10 squared is 100. This one is a little interesting. So 10 to the power of what is 10 to the power of negative 2.6? It's actually a very silly question. Of course the answer is negative 2.6. And later on we're going to learn something, a logarithm law that's going to help us evaluate this logarithm. But for now, you just have to apply the logic that I just said. Next one, they tell me that there's only 3/4 of the original carbon-14 remaining, and just sub it into the equation, and you can evaluate the number of, or how old the bone is, which is about 2374 years. For B, they tell me that there's 10% left. How old is the bone? So just sub it into the formula and evaluate. For C, rewrite the formula in exponential form, so just isolate for R essentially. And then for D, using your answer in part C, you can calculate the percent of carbon-14 remaining if it died 100 years ago. So if it died 100 years ago, the math is actually really interesting because there's 98.8% of the carbon-14 remaining. And this number is very close to 100% because carbon-14 has a very, very long half-life. It takes a long time for it to decay to 50%. So 100 years is actually not going to give you much of a decrease. But that's more of a scientific thing, and it's really interesting why it's 98.8%. Number 5, they're asking us log base b of x is equal to the exponent to which the base b is raised to produce x. So use this definition to explain why log base 4 of 4 to the power of 20 is equal to 20. So this is very similar to 3D. So the way I tried to approach this is I actually changed it to exponential form. I changed it to exponential form, and it makes perfect sense. It explains why that original logarithm in the question is true. 4 to the power of 20 is 4 to the power of 20. Another way of saying it is it makes sense that when you evaluate the logarithm, the answer is 20, because 4 to the power of 20 will give you 4 to the power of 20. I know it sounds repetitive, but really that's the logic you need to answer that question. For question 6, it's a pH question. C is the concentration of hydronium ions. Let's see. They give us the concentration and then basically just sub it into the formula and solve for the pH. And then express in exponential form. Basically go from logarithmic form to exponential form. Just be careful, because you want to isolate for C. Before we go to exponential form, just multiply both sides by -1. And for C, if the pH is 7, you can solve for the concentration of hydronium ions. It's just 10 to the -7 moles per liter. Okay, this sheet was pretty straightforward. Hopefully you found that to be the case.